Climate models have the long-standing issue of simulating summertime climate over the central U.S., having too warm of a near-surface temperature, not enough precipitation. This warm and dry bias are due to misrepresentation of a variety of processes from the atmosphere, from the land, and from the interactions of those two. One of which being that conventional climate models are unable to capture the mesoscale convective systems, which could deliver more than 50% of summertime precipitation. As a result, soil moisture deficit may develop, leading to underestimate evaporative fraction, positively contributing to the 2-meter air temperature or T2N warm biases. As the community moved towards convection permitting simulations, it's natural to wonder, will the surface climate over central U.S. during summertime be improved in those CPM simulations? Our collaborators at PNL, they've done a high-resolution WALF simulation over the majority of the continental U.S., covering from May to August of 2011. In Feng et al. 2018, they've shown that this high-resolution model with horizontal resolution 4 kilometers, or vertical 65 layers, are able to capture the MCS characteristics and statistics quite well. So in this animation, it's a short period of the simulation showing the rain rate and MCS mask from the observation from the Wolff-Morrison simulation and the rain rate bias of lower left panel. So the MCS signals are reasonably simulated, but what about the 2-meter air temperature? The upper left panel is the Wolff-Morrison simulation T2M bias, summertime 2011. The MCS-enabled high-resolution WALF simulations do suffer from the warm biases. As a matter of fact, the Morrison simulation performed better than the Thompson simulation. That's why it's shown here. The largest magnitude occur around Nebraska and Kansas is about 4 Kelvin, and at ARM-SGP site, which is denoted by this blue star, it's about 2 to 3 Kelvin. If you zoom into this ARM-SGP site, where high-quality data is readily available, and look into the daily mean value evolutions of the accumulated precipitation, that's on the upper right panel, evaporative fraction lower left, 2-meter air temperature lower right. The evaporative fraction bias is largely negative, while the T2M bias is largely positive, and the trend of those two is reversely correlated. So comparing to Morrison Wolff simulation, the Wolff-Thompson simulation has less accumulated precipitation, lower evaporative fraction values, and larger T2M warm biases. When you look into even finer temporal scale, say the diurnal cycle, the lower left panel, the T2M diurnal cycle, the summertime at ARM-SGP, the warm biases occur throughout the day in both simulations, in both the Morrison and Thompson. And for the diurnal cycle, the Morrison simulation again performs better than the Thompson simulation. For the better performing Wolff-Morrison simulation, actually you could decompose the T2M into 3 category composites. The first category, MCS events. The second, the non-MCS with precipitation events. The third, the non-MCS without precipitation events. The lower right panel shows the conditional mean of different components at our SGP site. So all the 3 categories have warm biases in the T2M conditional mean, and it's particularly large for the second category. Additional analysis at the central facility site suggests that the T2M bias contribution from the second category is particularly large due to both its frequency and conditional mean term. So the take-home message is, for the CPM simulation to have a good performance on the T2M over central US during summertime, a good performance of the MCS is a necessary but not sufficient condition for that. The non-MCS with precipitation events matter a lot here. In terms of research outlook, there are a variety of questions we could answer in terms of from the lens of CPM, and in particular, can the most critical aspects of CPMs impacting the simulations of coupled water energy cycle be identified so that we could prioritize our efforts to improve CPM simulations. With that, I'll end here, and I'd like to thank our collaborators at PNL for their support for this ongoing project, and I'll thank you for your attention.